In this video, I'm going to be talking about some final year project ideas that might be suitable for you in your final year project at university. In my former job, I was a senior lecturer where I actually ran the final year project module and supervised up to 15 final year project students at a time. These are, of course, all going to be relevant to CFD in some method, whether it's aerodynamics or heat transfer. So hopefully these ideas will give you maybe some food for thought, or if not, at least give you a beginning of a discussion with your supervisor. So before I go on, I just wanted to let you know that I've created an automotive aerodynamics course. Looking at fundamental bodies, here I've used the Windsor body. And the course goes through the fundamentals of fluid mechanics and bluff body aerodynamics. We do some work in Design Modeler, where we create a geometry and then parameterize it. Do some great work with meshes that are optimized for automotive aerodynamics. We get great convergence. We teach how to set appropriate boundary conditions, whether you're looking to replicate a wind tunnel or CFD test. Create some really cool images in post-pro, particularly using some of the methods we use in industry. We use expressions. I've done some videos on expressions before that you can see, but these are used as part of the main analysis. And then the course finalizes with an optimization study where we use the input parameters, match the output parameters, and then do some data analysis to work out which are the best tools to use to minimize drag on the Windsor body. So if you want to take a look, you can either follow the QR code at the top right or check the link in the description. I'm giving away the first places for $24.99, and after that, they're going to be $49.99. So the first final year project is a spoiler height and angle of attack, where we take something simple like a reference body or maybe a different car geometry that you're interested in, place a spoiler in the domain, and then use Design Modeler and the parameter tools within ANSYS Workbench to shift that up, down, rotate it relative to the vehicle, and measure CD at the same time. So you can see either my course or some previous videos for how to do that using parameter set, and I'll leave a link in the description to the parameter set video. That's a really cool option because it gives you these two variables, height above car and angle of attack versus drag coefficient. You notice here all of the videos I'm showing use that parameter set tool because what you want in your final year project is a data set that has a relationship between kind of what I'd call X and Y, where you're showing that changing a height or changing angle of attack has an influence on the output. You tend to do really well in final year projects if you can create graphs, show some visualization, and explain why these things are happening. That's what your academics are looking for. A few years ago, I had a student who worked for a refrigeration company and they made commercial cabinets. So in this case, you can see what's a cross section of a refrigeration unit here, where a customer would stand here and they would reach for items that are stacked on the shelf, in this case backwards into the shelf. And when we did these simulations, we set the regions behind the shelves as cooling inflow, so cold at some temperature. We specified this region as like an outflow region or an outlet, and the region down here as outlets as well, with a slightly negative pressure to act as basically a fan to draw flow down. We didn't model inside the cabinet because it would be too computationally expensive for this type of project, but you can vary inflow temperature, inflow speed, fan speed, and you can determine using little subdomains inside these shapes and with specified materials what temperature they get to, maybe what pattern of stacking is appropriate, what shelf spacing is appropriate, maybe what inflow speed is appropriate to minimize energy usage. Quite a complex project, will take a bit of sitting and thinking about and organizing, but is really cool. I found it really interesting to supervise, and if you have an academic who's happy to, you could do it as well. So, former student is something that occurs at most universities. I've taken this generic image on the right hand side from grabcad.com, so if you just look it up, you should be able to get the same CAD model. Aerodynamically, you can optimize a number of areas, including the nose profile, air intake profile, front and rear wings. You can add those on. And one of the things I found really interesting was adding a little fairing to try and mitigate the influence of the driver, because it's quite a bluff body there, blocking the flow. So you could add something here, almost like the halo system, just to deflect air around. I did have a student once do the air engineer intake profile, so just changing the cross section here so the flow is uniform across radiators. Try to only do one of these, because I do find, or when I used to supervise students, they used to try and do maybe 2 or 3 of them, and they used to melt. They used to do not a very good job. Try and do the least possible, but attack it really well. So do a nose profile, but maybe do a few parameters, such as front radius, height of that position there, and maybe that position there, and do quite a lot of simulations based on the same thing, and post-process it well. And the final project is actually one I finished recently with a PhD student, or something similar, where if you imagine this top right image is a simple channel flow where you have an inflow temperature, you have heat fluxes on the wall, and you have an outflow temperature. What his work was doing was adding roughness elements to the wall of different shapes, different spacings, different heights, to try and maximize the amount of heat transferred between the inlet and the outlet. But another really important parameter is actually the pumping power, so trying to minimize the pressure drop between the inlet and outlet while maximizing the heat transfer values. So a really cool project, relatively simple if you set yourself up in Design Modeler at the beginning, specify the shapes in CAD with all the appropriate dimensions, and then just shoot through them. Make sure your heat transfer values are in CFD post as expressions, and then the data will just spit out into parameter set. Again, if you want to know more about that, you can always have a look at the previous video, which will be in the description. And that's all I've got for now. I am planning another one of these videos. If you have any ideas you might want me to check, feel free to drop them in the description. And have a look at climatecfd.com. I've done some updating recently and will continue to do so in the next few months. We're now offering thesis proofreading simulation help if you're really stuck and just need someone to help set up or maybe bug fix for you. And if you're looking to book online or in-person training, if that's appropriate for you, your company, or your university. Thanks for watching, and I'll see you again at the next one.